Hello, my name is Martin Bessel, and in this demonstration I will showcase Quokka, a service ecosystem for workflow-based execution of variational quantum algorithms. To give some background, I'll briefly showcase the typical tasks of a workflow-based variational quantum algorithm implemented in BPMN. To facilitate the workflow's implementation, in previous work we have introduced an extension providing custom quantum tasks. The first step of a variational quantum algorithm is the generation of a quantum circuit solving the problem at hand. In this case, a parameterized quantum circuit is generated for a traveling salesman problem. Next, the circuit needs to be executed on a quantum computer. As current quantum computers are still noisy, readout error mitigation can be performed using classical post-processing to reduce the impact of occurred errors. As the quantum execution does not directly give us the solution for our problem, but rather returns a set of bit strings, we still need to evaluate it. Finally, the parameters of the Quokka circuit are optimized until convergence, resulting in a final solution representing, in the case of our TSP example, the best found route. To support developers in implementing each of these tasks, we have developed the Quokka service ecosystem. It consists of an API gateway and 5 microservices performing each of a variational quantum algorithm's tasks. The Quokka gateway is a Java-based API gateway facilitating the request routing by uniting all services in a single REST API. The Quokka microservices are implemented in Python, enabling easy integration of the currently predominant Python-based quantum SDKs, as for example Qiskit. Therefore, developers can easily extend the services by integrating their own scripts and programs into them. Next, I'll showcase a demonstration of how a variational quantum algorithm solving TSP with Quokka can be modeled and deployed using workflows in the Quokka service ecosystem. To model and deploy the workflow, we'll use the QuantMe modeling and transformation framework, which supports BPMN and uses the Camunda workflow engine. Before deploying the workflow, we still need to transform our quantum-specific tasks into standard-compliant BPMN modeling constructs. By pressing the transformation button, a repository is searched for suitable replacement fragments, which are then integrated into the workflow, replacing the quantum-specific tasks. Next, the workflow can be deployed by simply pressing the Workflow Deployment button. After the workflow is deployed, we can switch to the web interface of the Camunda engine and start our workflow via the Camunda task list. Therefore, we click on Start Process, then select our workflow, and first of all, enter our problem instance, and afterwards enter our IBM credentials so we can use QPUs, or due to currently long due times, fall back to noisy simulators. As executing quantum circuits with a full noise model is quite time-consuming, we here decided to only go with measurement errors. Therefore, we tick this box. Furthermore, we could adjust the optimizer, the objective function, or initial circuit parameters. After everything is configured, we can click on Start. Afterwards, we can go to the Camunda cockpit, then select our process, select our started workflow, click on the workflow ID, and then we can observe our workflow. To observe the progress during the workflow execution, simply refresh the page. As we can see, we are now in the 7th iteration of the quantum algorithm and can observe the intermediate results and parameter values. To check if the process is finished, we just refresh the page again. And when a workflow token reaches the Analyze Results task, we know that the algorithm execution is completed. We can check out the final parameters and then head over back to the task list, create a simple filter, claim the user task, and then check out the result. Right-click the link, open it in a new tab. The file is downloaded and then we can open it. The final result shows a visualization of the optimal route that was computed by our TSP algorithm. Thanks a lot for your interest in our research. If you're interested in a more detailed description of our work, you might want to check out our demo paper. If you want to try out our ecosystem yourself, there's a link to a step-by-step tutorial in the video description, explaining the setup and all the components in detail.